Greetings everyone. We as a group consisting of Hitik, that is me, Lakshya, Abhijit and Puryansh are presenting our work on Diesel social networks. So let's move on to the introduction of our dataset. So this dataset was acquired from Deezer, that is music streaming platform company in November 2017. So we are implementing some key metrics like betweenness centrality, clustering coefficient, page rank, and in degree. This dataset comprises of 41,773 nodes, which represents artists and users, and edges are 1,25,826, which denotes interactions. This dataset is comprising or was taken from Romania country. Moving further, Apache Spark. Apache Spark is a cluster computing platform designed to be fast and for general purpose. The main feature of Spark is its in-memory cluster computing that increases the processing speed of an application. So how will configure Apache Spark and an IntelliJ IDE? Let's see that. So we are using Scala as a language to implement our functionalities. So we need something called as SBT to make our code run. So we have built out SBT here. We have Spark version 3.5.1 to make this code run, and we have dependencies like graphics, JLine for input, command line input, Spark SQL, and Spark code. Moving back to PPT. So HDFS. What is HDFS? Hadoop Distributed File System is a fault-tolerant designed to be deployed on low-cost commodity hardware. So what happens is it is used when we have large input data sets. So that data set gets divided into multiple nodes, and one node is made as master node, and other nodes are made as slave nodes. And when we run some big functionalities or codes, so these input gets accumulated and the code is run. So how we are configuring in our project is we are using built-in ID of IntelliJ. We are working for two nodes in this project, and we are creating jar file out of that, and we are making that run. Moving further. So functionality. So we have worked on in degree, between the centrality, clustering coefficient, and page rank. First one is in degree. So in degree of a node typically refers to the incoming edges to that particular node, which this may signify the popularity, influence, or engagement level of artists within the Deezer platform. Nodes with high in degree values may represent influential artists that attract significant users. Moving further, so how this runs is we are using Hadoop's MapReduce feature. So MapReduce is a programming model or a pattern within the Hadoop framework that is used to access big data stored in HDFS. For example, we have taken an example here. If a Hadoop cluster with 20,000 servers and 256 MB block of data in each is centralized, then 5 terabytes of data can be processed at the same time. So this reduces the processing time to a significant level for such a large data. So moving on to IntelliJ to make this code run. Here we can see some logs are coming up, which means we have connected to the Hadoop and Spark. So here we got our result. This is our output. Let's go back to PPT again. So this is the result for reference in PPT as well. This is the result, and the same is being represented in graphical form.
So, greetings everyone. My name is Suryansh, and today I'm going to discuss about the betweenness centrality. Betweenness centrality is a measure used in graph theory to quantify the importance of a vertex within a graph based on the number of shortest paths that pass through it. High betweenness centrality indicate vertices that serve as bridges between different communities or clusters within the network. So now we will see the working of algorithm on IntelliJ. So now this is the code for betweenness centrality. Here we have uploaded the file graph.txt, which is here. This code is used to construct a graph from edges. This is to compute the betweenness centrality for each vertex. This is for normalizing betweenness centrality values. And this code is used to find the top 5 vertices with highest centrality. This will print the top 5 vertices with highest centrality. So now we run the code. So as you can see, the process finished with exit code 0, which means our code is correct. And here you can see the output. So now this is the result. And for that result, we have constructed a graph. Now we will discuss some of the applications of betweenness centrality. The first application is that in Deezer, suggesting tracks by users with high betweenness centrality helps in recommending music from people who connect with different music groups. The second is these users introduce songs that appeal to various tastes, helping listeners explore new music styles. Third is by checking out their playlists or recommended tracks, Deezer users can find a wide range of music genres and artists, making their music discovery more exciting. Then, fourth is this approach encourages users to try out different types of music and keeps them engaged with the platform. Now, I would like to invite Abhijit Singh for discussing clustering coefficient.
So hello everyone, I am Abhijit and I'm going to discuss about clustering coefficient. So clustering coefficient of a node in a graph measures the degree to which its neighbors are interconnected. So a higher clustering coefficient indicates that the node's neighbor are more likely to be connected to each other, forming tight clusters. So Apache's Spark X Graphs library is used as a powerful tool for distributed graph processing via built-in HDFS plugin in an IDE. So GraphX provides a high-level API for manipulating graphs and performing graph algorithms on a large-scale basis. Yeah. So now let's see the working of this algorithm on IntelliJ. Yeah. Yeah. So this is the code for this clustering coefficient. Here you can see like this thing is to load the data sets and construct edges. This is to construct a graph from edges. This is to compute triangle counts from each vertex. As you can see, this is to compute degree for each vertex. Now, let's execute this code. So as you can see, it is successfully executed. Let's see the output. Here we have, you can have a look on it first. Okay. Okay. So this was the result. Vertex 2683 has the highest clustering coefficient as we can see, which is 0.5. So let's quickly discuss about the applications of this clustering coefficient. So using the clustering coefficient in Deezer helps group user into community based on their music preference and interactions. This means we can find the cluster of listeners who enjoy similar type of music taste. By identifying these communities, Deezer can offer personalized music recommendation tailored to each group's tastes, making it easier for users to discover new tracks they like. So now I'd like to call Laksh to discuss further on.
So till now we have discussed different interferences of the dataset that we have chosen, that is the Deezer dataset. Now we will discuss about the page rank. So what is basically page rank? Page rank signifies the popularity of the entities within the dataset. Users interact by listening to songs of artists which are uploaded on Deezer. Here the algorithm is signifying the popularity of each artist based on the number of interactions. For the better understanding of this, let's uh, go to the IntelliJ and discuss about the code. So here's the code of the page rank that we have written. Here we have load the data and construct the edges, RDD. Here RDD is representing to the resilient distributed data set. Here we have constructed a graph from the edges, compute the page rank, and find the top 5 vertices within the highest page rank. Then later that we have print the top 5 vertices with the highest page rank. So let's go and run this code. So here's the output that we have got. Wait a second. Here's the output that we have got from this code that we have run on the dataset Deezer. So here's the output, and here's the visualization of the output that we have got from the this particular code. So what are the applications of the PageRank? Page ranking into the Deezer's recommendation system can enhance the visibility of the lesser known tracks by leveraging the concept of link analysis from web search engines. The second one is the page rank assigns importance scores to each track based on the number and the quality of the connections, that is recommendations, it receives from other tracks. The third one is the track that receives recommendations from the popular or highly ranked tracks will have higher page rank scores. That is basically indicating their relative importance within the music catalog. The fourth one is about by surfacing tracks with higher page rank scores in recommendation list or search results. Users can effectively promote lesser known tracks to users, increasing their visibility and discovery. And the fifth one is about this help users explore a more diverse range of music and supports emerging artists by providing them with opportunities for exposure. So, what are the futures scope of work? We are looking towards the future, different data science technologies and the techniques and machine learning algorithms can be used to accurately group listeners and also recommend them the tracks. This can be done using more sophisticated recommendations algorithms beyond the ones implemented, such as collaborative filtering, matrix factorization, or deep learning methods, basically. So it was just a brief introduction about what we have done. Here is the full report of what we have done across the project. Here is the proper visualization about the project that we have done and the data set that we have chosen about to use different algorithm on it for different interferences. So thank you everyone.